here in the top toolbar where you have the hands and it says contour. You can click on that and it brings up the contour property box. The very first one is called geometry. I've calibrated the image and now I want to measure the 4T hole and see what the measurement is. There's 3 ways to measure it. A ruler, side to side. A hole, a circle, and that tells me what the length, the width over here on the contour properties. And then the really cool tool is an automated tool. It's called the ISO line. It's the second box. You click the outside edge, and then it gives you the length, the width, and the square based on that. So you can do it on anything, and that's telling me the size of that hole. So if I want to measure the 2T or the 1T, I can grab the edge of it. That's telling me, now again, that looks a little off, probably because there's a lot of noise. But that looks like it right there. So that's 2 ways. That's another way to measure. So if somebody's sometimes I hear this all the time. Hey, is there a fast way to measure? I showed you 2. One is using the magnifying glass and then just kind of going over and looking at the sizes in the bottom. The manual is drawing a ruler. Or using contours. Contours, you can do it by box. Isoline, it will outline it. Circle, you can actually draw. If you wanted to, you could try to draw around it. It's a little harder to do, but it's impossible to draw. So that's a way to measure. And then measuring in units, micrometers, inch points, millimeters. The next one is density, and we were talking about that before. In the box, in the contour, I want to get an SNR, signal to noise ratio, or I need to know maybe how much porosity is in a certain area or whatever else. I can draw a contour box and I can say what I want that contour box, how big I want it. This one is set to 15 by 15 pixels or 20 by 55 pixels, but I'll just say 20 by 55. I draw a box, I say, okay, it's going to automatically adjust that box to 20 by 55 pixels. And then it gives me the median average, again, the density of the contour box. So that's what density, when we talk about optical density and we talk about density, that's what that's talking about. So this is giving me the average. Why do I need this? Part of we were talking about before, standards require signal noise ratios. A signal noise ratio is how much static or how much noise is in an image. If you have more static or more noise in an image than you have signal, it's not a good shot. So how we determine that, I'm back here up at the top, SNR. I click on that. I choose my 20 by 55, and if you can see that, the SNR is 362.9. The SNR normalized is 201. The normalized is the SNR minus the sigma. SNR values for class A versus class B would be 70 value or 99 value if you're measuring in the weld in the heat affected zone. Go back here. If you're going to measure SNR for this image, you're supposed to measure it in the heat affected zone, which is called the HAZ. You measure it right there. Make sure it's not in the weld. And that says 343 and 190. Anything above 100 for class A or above 140 for Class B qualifies. So these are both of these are way over that number. So this would qualify for the most stringent SNR, which would be Class B. I know that's a lot to take in, but signal to noise is one that comes up quite a bit. And then here's the value. So when we did our duplex, go back to the duplex real quick. When we do our measurement on the duplex, you would pull up this EN 14787 or the contour box, draw your line around your duplex, giving you the median average, all this, image analysis, SRB. So it says 160 micron. It automatically puts that in the SRB or the basic spatial resolution, and it gives your SNR at 185 and your SNR normalized at 102. Now, why is that? Because this is a different image, thinner part than the pipe that we just shot. Maybe we didn't have enough frames. Maybe we didn't have enough dose. Whatever it is, this normalized number may or may not qualify based on whatever code you're working to. It does actually, but for this, only because I know this image, I would reshoot this probably again, because my SNR, you see how the SNR here, when I'm pulling the box around, it actually qualifies. So I knew it qualified, but it doesn't qualify in the duplex, but that's not where you measure. You have to measure outside the duplex.